This presentation is intended to summarize the results and conclusions of the work that was done on the ASE number 4 in the Misener-Hunton Reservoir in Seminole, Oklahoma. This map shows an outline of the acreage in yellow under which leases are held and available for the exploitation of the Misener-Hunton, along with shallower horizons that have shown to be productive in the area. This slide shows logs from each of the wells drilled on the yellow acreage from the previous slide. All the wells that were drilled deep enough are presented here, and as you can see, between these two green lines is the Misener-Hunton, and it is in every well that went deep enough. Some are a little thinner than others, but it gives us an idea of which way the reservoir is going so that we can continue to lease up acreage in order to fully exploit it. You can see also these green bars that are mudlog shows in the Misener. We did not have the mudlogger on early enough here. And this one, for some reason, the show is in the Woodford Shale, which is the source rock for the oil in the Misener-Hunton and is also exploited in eastern Oklahoma and Arkansas as an unconventional reservoir. As you saw on the previous slide, the Misener-Hunton is in all of the wells that went deep enough. We tested several of the others and were unable to get a commercial volume of production from them after having stimulated only with a small amount of acid. So we knew that something else was going to be necessary, but we also knew that if we didn't do it right, we would harm the reservoir and not be able to recover what we believe was there. So in order to figure out exactly what we should do, we decided to take a core in the next well that we drilled, which is the ASE number 4. In the slides here, it simply depicts the process of taking that core, where we attach the core bit to the bottom of the drill string. It's a hollow bit that has a big hole in the center of it so that it cuts a donut, and the core inside across the section that we're interested in slides up inside of the aluminum barrel that is inside the coring, all of the coring equipment, so that we can recover it and then take it to the lab.
Okay, here is the aluminum inner barrel going inside the coring assembly. This is a 30-footer. And the core will come inside this barrel. It's aluminum, so it's easy to cut up. You can see the core bed being screwed on the bottom of the assembly right there. It's got a hollow center to it, and the core will go up in the center, up into the inside of this, into the aluminum core barrel. Let's see it, 60 feet up. This is the second 30-foot barrel. It's going to be attached to the first one to give us a total of 60 foot of aluminum barrel inside the coring assembly. torqued up. This will be slid down in the assembly that's there and giving a total of 60-foot coring assembly with a 60-foot aluminum barrel inside of it.
Of the 60 foot of core that we drilled, we managed to recover 52 feet of it. The rest was crushed and left in the hole. The core is then cut into 6-foot lengths for shipping, right here. And then once it arrives at the lab, it's cut into 2-foot lengths, and then we slab it. That is, we cut it in two. And after we cut it in two, we take plugs every foot from the core itself for further testing. And we take those slabs and we shine a ultraviolet light on them and show that the reservoir is in fact saturated with oil. Water does not fluoresce. Oil fluoresces under ultraviolet light. With the core out of the ground and at the laboratory, we continued to drill the well down to total depth below the Hunton.
Yeah.
This is the area over which we recovered the core. This is a mud log, and it's made from samples recovered while drilling. The oil shows as fluorescence in these particles that are recovered from the pieces of rock that are drilled up and brought back to the surface. You can see that here they've noted a good show across this depth from about 65 to just past 4,000 feet. This indicates that we're looking at a carbonate. This is an indication of the speed at which it was being drilled, and we had a good gas kick at the top of it. All of these things indicate that we've got hydrocarbons in this section in this wellbore. It confirms what we did see on the core. Not that we needed any confirmation, but it shows us exactly the same thing. This is the log across that same section. It's the open hole log. It shows here good carbonate development. Right there on the gamma ray, the SP log, which is an indirect indicator of permeability, shows that we have good permeability and it's pretty clean. This green section up here is the Woodford Shale that I mentioned to you earlier, that is developed elsewhere as an unconventional resource. Lots of horizontal drilling, lots of multi-stage fracturing, but we're focused on this section just underneath it. This here is the microlog, which is a calculated log. It's measured to look at the resistivity of the 2 inches around the wellbore, just 2 inches away from the open hole. And it's an indication that right here that we have permeability. Out here is the porosity log. It's telling us, because of the red line being below the green line, it's telling us that we've got a gas effect, which means it's either pretty light oil or it's kind of gassy, and it has porosity on the order of 10%. The important item is right here. This is the resistivity of the reservoir. This big kick out here actually on the red curve. This big kick out here is an indication that we have resistive fluids in the wellbore or in the reservoir, which is an indicator of oil. As you see it start to slide back here, that's an indication that we have increasing water content, saltwater content in the reservoir, until right about here, which is where we come out of the bottom of the carbonate or the Misener-Hunton. So we've got good solid column of oil here with a transition zone. I should also mention that we have really good containment to the reservoir. We know that it's not breached because above us we have, as I mentioned, the Woodford Shale, and below us we have the Sylvan Shale, which is again a nice solid block for any work we do in here, so that we know that we're not going to break out below this into these wetter sands down below us. So what does the core, in conjunction with the log, say about the Misener-Hunton? Well, the fluorescence that I mentioned to you on the slabs, this is 10 feet of core right here. And we had, as I mentioned, 52 feet. So the fluorescence says that it's saturated with oil. Even though this core was recovered while drilling fluids were being circulated, it shows that there's still a significant amount of oil that remained in the pores. Here is an indication of the kinds of pores that we've got. This is secondary porosity. It's called vugular porosity, and it's caused by dissolution of the rock by moving groundwater just after the time it was laid down. Just when it begins to lithify, the groundwater is moving through it and starts to dissolve it out. Okay, so that's secondary porosity. The study of the lithology that we made from the cores right here, it tells us what environment the rocks were laid down in. In other words, was it laid down in a deep ocean? Was it laid down close to the shore? Was it laid down in an intertidal zone? Was it laid down in a lake? In our particular case, this is all what we call the intertidal zone, for lack of a simpler term for it. And in here you can see all these little dots in here. All these little dots are the lithologist telling us that there's vugs, or these open spaces, all the way up and down through this core. There's no reason not to expect that to be in the rest of the reservoir, and this covers pretty much the entire thickness of interest. The saturation studies that we did are here, and we can talk about them later, but what they effectively told us was that there's a high amount of movable oil here, and we'll go on to explain how much that was later. And then we also did some rock mechanics studies, these stress strain diagrams and a whole lot of other diagrams that told us what was going to be necessary to, what kinds of forces and pressures and volumes would be necessary when we stimulate this reservoir, because we now know that we have to. All of this, as a combination or as a group, confirms and adds to what we see on the open hole logs. So, what did all of that tell us? Well, it tells us that here, by comparing the oil saturations from the logs, which are and the cores, it tells us that there's a 40% of the oil in place is movable. The log data shows out here saturations in that 70-80%, 60% down here, 50% closer to the bottom. But you can see we've got terrific saturations of oil out here. This is a saturation from the core data. Now, what the core data is telling us is that all that oil that was in place, or all the volume that was in place, has been moved out. So there's, that's running about 20%. That's the amount of oil that was responsible for that fluorescence that you saw, that could not be flushed out by the drilling fluids when the core was being cut. Okay, so the difference, if you look at the volume difference between the two, there's about a 40% volume of oil that moved. It's anywhere from, depending on what you think the average is here, and we actually obviously can calculate all of that. It works out to about 40% of the oil in place uh, from this entire section is movable. Movable simply means that under the right conditions, you can get it to come to the wellbore. 40% of the oil in place is a big number. That's really quite attractive. Over here, we took a look at what the log porosity appeared to be versus the core porosity. The log porosity is severely affected by the amount of shale that's distributed in the system, and by whether or not that porosity is interconnected. The core porosity, again, which is the green curve here, is after it's been dried and cleaned up so that we can force a foreign fluid through it and measure the volume of fluid that stays behind in the core after we fully saturate it again. This black line out here is an indication of how much of that pore space, how much greater the pore space from the core is than the log for the same depth. What that tells us is that a significant fraction, it's only, by the way, if you look here, it's at 50 to 60%. The logs are 50 or 60% of the core data. That tells us that we've got a whole lot of vugs, a whole lot of secondary porosity that's not interconnected, that won't contribute unless we figure out a way to join everything up. So we figured out from the core that we need a stimulation, but what kind? We settled on a sand-supported stimulation using gelled water and nanoparticles. It was injected into the reservoir, uh, and uh, and it broke the reservoir down, and the nanoparticles provided kind of a boost through Brownian motion and disjoining pressure, and we put about 2,000 barrels of it into the reservoir.
So as of today, we have 268 barrels recovered of our 2,000 barrels of frac fluid that we put down the hole, and basically just water with a food grade gel in it with the sand. So it's very environmentally, we're very environmentally conscious. These are good products, and we put those under high pressure, and so far have about 15% of that load brought back. As we bring more of that load back, there will be more oil coming back. So we're just really looking forward to this and very excited about the prospects moving forward.
Could you take the top off of the oil sample so we can
Sure.
show a little quality of the oil?
Don't light any matches around it.
Oh yeah, that's nice.
Very nice oil. Yeah.
Yep.
This gives you just another view of all the equipment that we have out here. Still rigging everything up.
So now that you know what we were trying to accomplish with the stimulation, and you could see from the jar on Mr. Pierce's desk that we were already getting oil back, we thought we'd take a look at really how the reservoir is responding. It stimulated as expected. It took the fluids, it broke down about how we expected it to break down. However, we did expect it to take 4 or 5 days for oil to show up as we started to bring back that 2,000 barrels that we'd injected into it. However, it came back in 24 hours. That it came back with just terrifically flowing fluids, load water, and some oil along with it, and a lot of gas.
This is our third swab of the day. You can see a lot of foam, a lot of oil in the bucket. Cleaning up nicely.
Okay, guys, we're here with Dean. He's going to explain the progression today.
So you can see we started out with pretty dark water, but it's separated out. Still got an oil film on top. A lot of sediment with oil on the bottom here. But as we progress through the day, you can see things getting darker and darker and darker. These last three samples really didn't separate out. So we've got water mixed with oil in there, but we've got such a large oil volume with that water that it's not separating out now.
Cool.
Just a real good sign.
How about the pressure? Did we get any blows intermittently?
We got blows all through the day. You saw those in the videos I sent in.
Okay.
Really strong reservoir response. And the good thing is we actually started tagging fluid at 1,600 instead of 1,700.
That's good.
So as we bring that water off, the oil's coming in and we're getting a little bit more volume come in.
So, what can we conclude from all the work that we've done? First, the Misener-Hunton formation underlays the entire acreage position and beyond. The logs from the offsetting wells indicated oil, but when we tested them earlier with a small amount of acid stimulation, we couldn't get them to produce. So we knew we were going to need something more, but we didn't know what. When we drilled the next well, the ASE number 4, we took the core. We confirmed that there is a large volume of oil in place, and it provided the information so that we could design a procedure that unlocked it. That procedure and the work that we've done with it since are effectively the keys to the kingdom. The nanoparticles that we added to the stimulation fluids, they seem to have contributed to the early arrival of the oil in the initial testing. It came in less than 24 hours, and we didn't expect it for at least 4 or 5 days. We had only recovered maybe 1% of the volume that we injected before it came back to us, and we thought we were going to need to get 20 or 25% of it back. So, although minor tweaking might be necessary, this stimulation method is expected to apply to the ASE number 1, 2, and 3, and many additional wells in offsetting acreage with the same level of success. The results are undeniable.